Hello, welcome to the ATC 24 community guide for how to control Aerodrome. This has been made in collaboration with multiple event ATCs and with multiple community members that are somewhat well known or that have decided that they will help in showing of physiology. Let's start off with picking a runway. When we pick a runway, we look at the wind in real life. We want to always fly into the wind, so if the wind is greater than 5 knots, then we will always pick the runway that causes you to fly into the wind. If the wind is any calmer, we will use either the preferred runway or something like the sun's position. If we're flying into the sun for landing, that is not ideal. We will usually take the opposite runway. It's usually not complex. On ATC 24, we will usually use pretty standard runways. For example, to Rockford, runway 25 is commonly used unless, well, people feel like it, then they can use runway 07, but that's down to them. When we have 3 types of altitudes or like heights, so altitude, height, and flight level. Height is the height above ground in reference to, well, the ground right below you. We will usually use height on QFE if we want to have the height in reference to the airfield, where it will display about 0 feet. Well, it should display 0 feet off the ground when you are on QFE that is at that airfield. We never use it for vertical separation, but thankfully it is not simulated on ATC 24, so it is not an important thing for you to know. What we do need to make sure we say is that we always say the altitude when, for example, giving a descent or a climb. So, for example, Wizz Air 90345, descent to flight level 70, or descent to altitude 3000 feet. Here you can see a diagram of the height above the airfield in, for example, feet or meters, because some countries like China or Russia will use meters rather than feet. So on your altimeter, if you have set it to a QFE, you will have the height above the airfield. The next parts are the altitude and the flight level. The altitude is the air pressure above mean sea level at any given point, and it will be the approximate elevation of the aerodrome that will be displayed on your altimeter. It is not a flight level, so you have to keep that in mind. It is the local pressure that is only used below the transition altitude in real life. But again, on ATC 24, it isn't required because, well, we don't really need to simulate it because air pressure is not simulated. Flight levels are on standard pressure, which is 1013.25 hectopascals or 29.92 inches of mercury. This is based on the search it up, I don't remember, it's like the ISO, I think, measurements, whatever you guys want to call it. Look, no, IGA, like International Global Atmosphere, whatever, something like that. One thing I should clarify is that flight levels are flight levels. There is no 065. For example, here, 10,000 feet is flight level 100 or 100, or 6,500 feet is not flight level 065. 6,500 feet on standard pressure is flight level 65. Here is a diagram. You can see that the airfield altitude is here. The elevation of the airfield is between mean sea level and the airfield. And on QNH, when your altimeter is set to QNH, it will display the altitude above mean sea level. The same goes for for flight levels, but as we fly, air pressure changes, so everyone just uses one set pressure so the altimeter will change technically while you're flying in real life. Again, on PTFS and ATC24, this is not simulated because we don't simulate air pressure. Now, linking into air pressure, we have transition altitude and levels. The transition altitude is the highest altitude you can fly out before you have to use, the highest altitude you can fly at on local pressure. Above is, and then the transition level is the lowest flight level on which you can fly out on standard pressure. And you cannot fly cruise between this. So if your transition flight level is flight level 120, and your transition altitude is 10,500 feet, you can be at 10,500 feet level, but you cannot be at 11,000 or 10,600 or below or between 10,000 and 12,000 feet, while you are on. You just cannot be, because you could essentially get into a conflict between aircraft that are on flight levels and aircraft on altitudes. This part is called the transition layer between the altitude and the flight level. The next very important part, you can go watch Flying Fundamentals made by the ATC24 staff officially for a more in-depth explanation. In short, METARs are your meta reports from an airport. It can have a maximum of 3 combined parts. For example, here you have a Romeo Echo, Delta Zulu, Foxtrot Golf. This all it means is a recent, drizzle, and fog. RE is always recent. So in this meta we have Lima Foxtrot Papa Oscar, which is the ICAO code. I think this is Paris Orly. I could be wrong. The date is 04. The time is 1300 Zulu. The wind is 360 degrees, 20 knots. It is varying between 320 and 040. We have 1200 meters of visibility. And on runway 26 we have a RVR, a runway visual range of 400 meters. So we can only see 400 meters from runway 26. RASH, the plus, all it means is that it is increasing in intensity. So the rain and showers are getting worse because of the plus. Broken is 3 to 5, 4 or 5 octas of cloud. So how much cloud you can see in the sky. It is more than scattered or few, but it's not overcast. So it's like 5 to 7, I think. It's out of 8 octas. So if you take a look at the sky, a little mirror, and if you look up, if that is completely grey, full of clouds, that is overcast. If you can see gaps, that could be broken. If you can see more gaps, that could be scattered, and just a few tiny clouds, that is few. In continuing on, TCU on the clouds means it is towering cumulonimbus. No, I'm wrong. Towering cumulus. All it means is that there are cumulus clouds that are towering, as the name suggests. The other very common ones are Charlie Bravo, which is cumulonimbus. That's why I got confused for a second. And Charlie Bravos are often very dangerous to fly in, and we always in real life try to avoid them. And if they're close to the ground, we don't fly at all, because they usually bring thunderstorms. Anyway, continuing on, 17 and 15 is the temperature and the dew point. If it said M17, that would be minus 17 Celsius. And regardless of whether you are in the US or anywhere in the world, everyone uses Celsius. You cannot use Fahrenheit. No one uses Fahrenheit in aviation. Q1015 is the pressure in hectopascals, as it is Q and H. We don't report QFE in a METAR. We only report QNH with the abbreviation Q, Quebec. And in this case we have Q1015, QNH1015. That is the local pressure. Well, the local mean sea pressure. RETS, as I explained earlier, RE, all it means is recent, and TS means thunderstorm. RETS, that means there has been a recent thunderstorm. You can see all the definitions below. The next part is traffic information. This is very important. This is what people miss on ATC 24 a lot of the time. We will use a scope, any scope, 24 RC, 24 scope, 24 sky, anything. That's 24 radar, anything that you can use to take a look at aircraft in the game. Take the position, imagine a clock. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12 is straight ahead. So 11 o'clock will be slightly to your left, and 10 o'clock will be a little bit more to your left. 9 o'clock will be directly to your left. 8 o'clock will be to your left, but a little bit behind. 1 o'clock will be a little bit to the right. 2 o'clock will be a little bit more to the right. 3 o'clock will be directly to your right. 4 o'clock, etc. 6 o'clock will be directly behind. Indicating 2,300 feet, it's the altitude. And if you know the aircraft type, give the aircraft type. So if you have two aircraft that are flying more or less towards each other, you can have one flying ahead, one flying backwards, one flying forward. So let's say we have one aircraft going forward on the right and one going southbound on the left. You can say, oh, you have traffic. Let's say they are in reference to the aircraft on the right. They are 10 o'clock, you can say, and they're 2 miles. You can say 11 o'clock or 10 o'clock, 2 miles, indicating their altitude, whatever altitude they're indicating. That could be 2,000 feet. And if you know their aircraft type, pass their aircraft type, because that could influence whether they're slow moving or not. Continuing on, we will always give the aircraft type and the aircraft information in relation to the 12 o'clock, so in relation to the clock. 12 o'clock, as I said earlier, is straight ahead. 3 o'clock is directly right. 9 o'clock is directly left. 6 o'clock is directly south. It is not reference to what you can see on your screen. It is reference to the way the aircraft is moving. On the ground, we give the taxiway, where they are going, and the aircraft type, and if you have the airline, then the airline. For example, if we're going to give to a Southwest aircraft type for a Wizz Air, Southwest, I don't know, 1611, traffic on Alpha, Wizz Air Airbus A320 on Alpha, passing right to left. This is how we also give conditional clearances when we have traffic that moves right to left. For example, we can give a aircraft taxi or pushback, but we can tell them behind the traffic passing right to left. Next thing, semicircular rules. We have IFR. They have to go east or west. When they go east or west, they fly at different flight levels. When they're going east, they fly even. When they go west, they fly when they fly east, they fly odd. When they fly west, they fly even. If they're going directly south, they will fly on an odd level, and if they're going directly north, they will fly on an even level. For example, Rockford to Tokyo. You're going directly north from Rockford to Tokyo, it should be an even level. If you're going directly south from Tokyo to Rockford, it should be an odd level. The same applies for VFR on flight levels, on like flight routes between, for example, between countries. If they're flying on a VFR route, they should be on a flight level, and they're on a flight level, they should be on a flight level like one of these, where it's 500 between. For example, flight level 905, flight level 85, flight level 75. If they're not flying on flight levels, you really need to do this. It's not usually like anything too important, especially with VFR traffic, because technically, as long as they're in uncontrolled airspace, there is no need for them to be flying on a specific east or west level. In terms of initial clearances, every pilot on ATC-24 must have a flight plan, regardless of whether they are VFR or IFR. In real life, VFR aircraft do not need a flight plan. On ATC-24, it is very important that we do make a flight plan because it is required by rules. Again, there are no pushback clearances, you simply just push an aircraft. On ATC-24, a lot of people do use chart packs, but they're not official charts, so though you can give these reference points, you do not need to use them as a pilot. So just for your own sake, use northeast, southwest, and any actual reference points in relation to the airport. For example, runway center lines, overhead. For example, if they're transit from the north to the south, you tell them transit from the north to the south, overhead not above 1,000 feet. Or in real life, you can be also given an exit point clearance using a reference point. We don't have reference points again, just give them north, south, east, west if they're departing. For example, in real life, you can have Golf, Alpha, Victor, Juliet, exit the East Midlands Control Zone via Church Broughton VIP, not above 2,000 feet, Squawk 3672. Now, we also have to take into account, with the next part, a VFR circuit pattern would be a standard left-hand pattern, unless your air traffic controller tells you otherwise. Else, you would just fly with a standard left-hand pattern. On ATC-24, we can apply very similar logic, and it is applied at some aerodromes without visual points, even though most do have visual points. For example, Lima Zulu Echo 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 exit Grindvik control zone to the south, not above altitude 1,000 feet, Squawk 0201. That could be a nice ATC-24 VFR initial clearance to exit the control zone. Simple, you fly south, you take off, you turn left from runway 26, or just you turn south, and you stay not above 1,000 feet, or at 1,000 feet essentially, and squawk is squawk. Next part is your circuits. Again, we specify the runway, the circuit, the altitude, the squawk. It's quite simple. We specify the runway. Well, you don't have to specify the runway, but you can, for example, say Foxtrot Sierra Kilo Romeo Alpha. Correction, no, not Foxtrot Sierra Kilo Romeo Alpha, right-hand circuit, altitude 1,000 feet, squawk 7010. Again, it is very important that we specify that it is feet and altitude, not flight levels, regardless of whether it exists or doesn't on ATC-24. And you can combine instructions if an aircraft calls you for taxi or startup. So, for example, Foxtrot Sierra Kilo Romeo Alpha, startup approved, right-hand circuit, altitude 1,000 feet, squawk 7010. Or taxi, Foxtrot Sierra Kilo Romeo Alpha, taxi holding point runway 245 Alpha, right-hand circuit, altitude 1,000 feet, squawk 7010. On ATC-24, you can give any squawk for an aircraft, but in countries like the UK, the standard circuit squawk is 7010 at controlled aerodromes. At uncontrolled aerodromes, it is a standard VFR squawk 7000 or 1200 if you are in the US.
Echo Sierra Golf Papa Alpha Cessna 172 at the General Aviation Apron Information Alpha request taxi for circuit patterns.
Echo Sierra Golf Papa Alpha, runway 24, right hand circuit 1000 feet, squawk 7010, taxi holding point runway 24 via Alpha.
Runway 24 right hand circuit 1000 feet, squawk 7010, taxi runway 24 right via Alpha, Echo Sierra Golf Papa Alpha.
Echo Sierra Golf Papa Alpha, correct. Report fully ready.
Will report fully ready, Echo Sierra Golf Papa Alpha.
In terms of VFR clearances, it will always consist of a clearance limit, a route, a climb, and a squawk. So if we have a SID, if there is a filed SID on ATC24, we will tell them, for example, in my example here, Scandinavian 5824, clear to Southampton, Canon 1 departure, runway 25 left, climb flight level 40, squawk 1426. Of course, it is not. It can look differently. Look different. You can give a different initial climb or a different departure runway. It is the SID identifier, and we specify that it is that departure. So via Canet 1 departure, sometimes just you can drop the word via, just to save yourself some time. No worries. There's not too much to it. There is an FAA clearance. It is the most standard clearance right now on here, but hopefully with this video coming out and people looking for more guides, I hope that will get replaced by a standard ICAO clearance, where we don't follow full craft. It is a simpler clearance. It's cleared Southampton, departure, runway, climb, squawk, done. Now the other type is an omnidirectional departure, which is there are three types: visual, vector, direct. Vectored is what we give by standard on ATC24, and it is always given for flights without a SID that are IFR. For example, Wizz Air 9345, cleared Perth, runway 25 left, fly runway heading, climb altitude 1000 feet, squawk 2742. Or if we're going to Grindavik, Shuttle 9 Tango, clear to Grindavik, runway 25 left, fly heading 240, climb altitude 2000 feet, squawk 2843. No, that's wrong. Ignore that, because that is my fault. You cannot have 8s or 9s in a squawk. Maybe I should have specified that. That is invalid. Oh wow, my window's opened. Blooper. Anyway.
Shamrock 961 requesting Alpha clearance for Isawakan at stand 1.
Shamrock 961, clear to Southampton, runway 24, climb altitude 1000 feet, fly runway heading, squawk 1437.
Clear to Southampton, fly runway heading 24, climb altitude 1000 feet, squawk 1437, Shamrock 961.
Shamrock 961, correct. You can use, it is very nice to use, and I'll probably request it as a little bit of a feature on ATC 20, well, not on ATC 24, on 24 scope. But by standard, if you are flying from Rockford to Meller, Rockford to Tokyo, Rockford to Larnaca, Larnaca to Zolorani, Zolorani to Tokyo, only via Rockford. So if you fly through St. Barth airspace, it does not count. Tokyo to Perth, Meller to Perth, Tokyo to Meller, or Perth to Zolorani, or vice versa. So it can be done both ways. It can be, for example, Rockford to Meller, or Meller to Rockford. Any work. You can give as ground or clear or whoever, if whoever's given clearance, you can give squawk 1000. It is, in my opinion, recommended. It allows, well, more squawks to be used. In my opinion, it's very interesting to use. something interesting, something different. Now, first of all, you need to take into account what levels there are to be minimum for Mode S airspace. So any aircraft, for example, Rockford to Tokyo or Perth to Tokyo, over Skopelos, Mode S is not available. So some Perth Rockford routes are not allowed, and over St. Bath it is minimum 3000 for Mode S for Squawk 1000. So you must be minimum 3000 feet filed if you want to fly from Tokyo to Rockford or vice versa and have Squawk 1000. Now, we assume on ATC 24, because Orange has not put in any radar domes, we're assuming that we look at not VOR DMEs but just standard VORs where radar is, where Mode S is. I don't know. I don't know. A few people decided that, and we just kind of agree on it. So Mode S is level with minimum sector altitude. So in any direction. So if the minimum sector altitude is the minimum sector altitude on ATC 24 is 500. Don't fly below 500 if you want to be controlled any closer. But generally we don't vector below 500. You can fly below 500, no issues, but we don't vector below 500 as approach or as control. And yeah, that's it. Unless you have visual sight with the terrain and you can take your own terrain clearance. But Gary does not have a standard VOR. It does not have Mode S. It has military. It has primary and it has secondary, but it does not have Mode S. So we don't assume that it can essentially pick up Mode S. That's why we have to be very careful. I'll show you on the next slide where we can use what. Rockford and Perth Easterlies don't use Squawk 1000 on the Rockford Perth routes. Why? Skopelos airspace. Barf a lot of the time can vector you through Skopelos airspace, especially on a Rockford runway 07 departure. So runway 07 and runway 11 departures should not have Squawk 1000 if they're out of Perth on runway 11 or out of Rockford on runway 07. Any of the 07s. And of course, some first place minimum 3000 be Squawk 1000. And we have a map. St. Barth 3000. Tokyo is from the ground. Perth over here is from the ground. Here is 2000. I hadn't taken this fully into account, but we could say that this is 2500 or 2000 for Mode S, or generally for like controlling. So you want to generally try to keep them on 2000, unless they're on the glide path or the ILS, the localizer, then they're fine. Anyway, you can generally see here. Near Gary it's 2000 feet minimum, and around here it's about 2000, 2400, 2500-ish. Generally around 2000 will do. On the ground, startups are very simple. Call sign, startup approved if they call you for startup, but it's not very common for airlines and commercial traffic, as they're usually parked facing towards the terminal. Now, pushbacks are the most common instruction on the ground that you will, or request you get in terms of starting up. It is a request push and start, or pushback and startup. The correct phraseology is a request pushback and startup. And for example, Speedbird 285 pushback and startup approved facing east. Unless there's only one way to face, then you can just say pushback and startup approved. And if they call you just for pushback, it's just pushback approved facing whichever direction. Unless there is no direction to face, unless it's for example on a Rockford, there's only one direction you can go. Just use that direction. You ready?
Tom Jet 4049 crest pushback and startup.
Tomjet 4049er pushback and startup approved face north.
Push and startup approved face north.
Now in terms of pushbacks, think, because you're going to block potentially other traffic in the way. Other traffic, for example, here you have two heavy aircraft. If you push this guy, these two cannot get out. If you push this guy, these three cannot get out. Of course you can if you believe this guy. If this guy tells you, yep, we're ready and we can get going pretty much immediately, push, get out. This guy can then get out and these two can get out. But it will block up generally the way of our traffic. On ATC 24 it is very rarely an issue because people are quick and there is not much to do. You push and you get going. Later, in terms of ground traffic management, taxiing. Taxi holding point, runway 25 left, 5 kilo and alpha. If we're at Rockford, runway 25 left is used for departure. Now, we generally want to give the maximum runway distance, so alpha 5. You can also specify holding point, for example, runner 077, taxi holding point, alpha 5, runway, correction, alpha 4, runway 25 left, or alpha 5, runway 25 left, 5 kilo and alpha. Now, the one important rule with taxi instructions that people miss a lot of the time, taxi paths must never intersect. And we'll go over this over here in a minute. With ground traffic management, you could say follow the traffic, holding point runway 25 left, or alpha 4 runway 25 left. For example, United 747 follow the Papa Oscar, the Sierra J7 to holding point runway 25 left. That will follow the traffic ahead to holding point runway 25 left. Any of these will do, as long as you specify who it is that you're following and where you're following it to. Now here is the taxi intersection methodology and thought process. You have an aircraft that is outbound, one that is inbound. This guy has vacated, let's say Delta, he is about here. He wants to get to stand 1-3. What do you do? This guy is ready for taxi, this guy is ready for taxi. Now stand 1-3 is here, so you have to tell this guy, stand by. This guy, well, needs to get out, so you tell this guy, oh, taxi holding point, runway 25 left, via kilo and alpha. This guy will taxi out. Now you cannot immediately give this guy this, because it will intersect. For example, I know, let's say, so what we do is we take this guy here, and because this will intersect regardless of how much time there is, unless they're directly following each other, then we always give to where it is safe. So for example here it's to holding point runway 25 left. Yeah, like this is the solution. You take this guy to 25 left, this guy, taxi alpha, Juliet 2, hold short of kilo 2. It's that simple. He will go here, turn right, and then hold short of kilo 2. Then later, when this guy's clear, you tell this guy, taxi stand 135 kilo. Done. Now, next important thing is aerodrome circuit management as tower. We have an aircraft, Victor Papa Lima Echo Lima. This is a made-up airport. He wants to join the circuit. You can tell him, join right downwind, runway 36. So you just tell him, this is because it's a right-hand circuit. join a right downwind, runway 36. So he will fly this way, he'll join, and he'll fly this way. Now, because this guy is not the final traffic, you need to make sure you tell this guy that there is a guy joining ahead. So Victor Papa, November November Golf, number 2, traffic ahead, joining the circuit downwind. You have to pass their position, and you need to tell him that he is now number 2, not number 1, because he was number 1. Lima Echo Zulu Sierra Foxtrot, 1 traffic in the circuit, currently upwind, report in sight.
Lima Echo Zulu Sierra Foxtrot, traffic is in sight.
Lima Echo Zulu Sierra Foxtrot, join right downwind, number 2.
Lima Echo Zulu Sierra Foxtrot, joining right downwind, number 2.
Is much later in the downwind. Having Victor Papa Lima Echo Lima join downwind is a mistake, because this could create a collision. So you tell him join beginning of downwind runway 36. He will go fly here and join beginning of downwind runway 36. And follow. You don't need to pass traffic information to Victor Papa November November Golf, because this guy is only joining the circuit. You can tell him that there is one other in the circuit. Victor Papa Lima Echo Lima, join beginning of downwind runway 36, 1 traffic in the circuit, and that's all the information you need to pass. You should always pass how much traffic there is in a circuit though. You can also put them on base, for example in the same position, where downwind is a mistake. You neither put them beginning of downwind, and if there is enough room, join right base runway 36, 1 traffic in the circuit. And then you need to pass Victor Papa November November Golf, that he is number 2, traffic joining base runway 36. So this guy knows where to look out for. If the situation is like this, you can tell Victor Papa Lima Echo Lima to make a straighten approach runway 36 and report final. Now the 2 standard instructions are always report downwind and report final, regardless of who the traffic is, as long as they're VFR in a circuit. Next part would be you can also join them on the opposite side of the circuit. So you tell this guy, Victor Papa Lima Echo Lima, join left downwind runway 36 to traffic in the right hand circuit. You should specify that it is a right hand circuit these 2 are on, because Lima Echo Lima is flying a left circuit, not a right circuit. So you tell Lima Echo Lima, join left downwind runway 36 to traffic in the right hand circuit, and for example report base or report downwind. That is all that he will do. He will join downwind, and he knows that there's traffic in the circuit. And these 2 should also hear that there is 1 guy joining over the radio. Again, you can also extend downwind. So Victor Papa November November Golf, if there is for example a large airliner, Victor Papa November November Golf, extend downwind runway 36. And this VFR traffic should continue going down until you don't tell the traffic to turn base. So Victor Papa November November Golf, extend downwind runway 36, and then later on Victor Papa November November Golf, turn base runway 36, report final. The other thing you can give it instead of an extension is orbits. The standard place to make them orbit is on a downwind, because it is furthest away from the other traffic, and make sure you don't turn them towards the runway when you give them an orbit. Victor Papa November November Golf, enter left orbit. That is how simple it is. Now the next important thing is VFR pushing a VFR, in the sense of a light, slow VFR traffic is flying final over the is flying final, and you have an IFR aircraft behind. You tell Victor Papa November November Golf, go around, or you can tell you can say Victor Papa November November Golf, go around, or you can say Victor Papa November November Golf, make another circuit. All it means is just fly another circuit. It's simple. this is to minimize delay because it is much faster making another circuit as VFR than having a large aircraft go around. This is all about efficiency. There is no general rule for VFR over IFR. Helicopter basics, it is no different from taxiing another aircraft. Just hover and air taxi is used instead. The last Now the final thing I need to talk about is the conditional clearances. When an aircraft wants to push or taxi your lineup for departure, you can give a conditional clearance. For example, Wizz Air 1611 behind the landing traffic, runway 25 left, line white behind. We must specify that it is behind just for clarity and to make sure they don't accidentally line up and wait if they didn't catch the first part. This applies for taxi push. You can have, for example, Wizz Air 1611 behind the traffic passing left to right, push and start approved, face north, or with a taxi, instead of saying behind, we say after. I know it just sounds better to my ears. I've only heard people say after. After the traffic passing left to right on Alpha, taxi holding point runway 25 left 5 kilo in Alpha. Well, that's made up, but the point is, you can give a conditional clearance at Rockford. It doesn't work very well, unless they're taxiing to a stand, for example, and then someone, for example, an aircraft is taxiing to a stand, one guy is outbound, then you can, for example, behind the traffic passing right to left, onto stand 13 on Kilo, taxi holding point runway 25 left 5 Kilo Alpha. That is the only time where it would work potentially. At Rockford it doesn't really work. At Tokyo and Perth it probably works a little bit better than that. A little bit better in Rockford. Anyway, thanks for watching. Radar soon. I've recorded a few videos, but it's not a lot necessarily, and I haven't made any PowerPoints or any slides relating to it yet. So yeah, live stuff. Let me know if you have any questions, or leave comments under the video, or just ping me at Bedstrout or at Polish guy at Nazi at 2316 Nazi or whoever. Just let me know if you guys want to have any questions or ask any event ATC 9 times out of 10. I can probably answer it. Anyway, ciao.